Three stories are moving through the AI engineering community today, and each one has a direct bearing on how you build and what it costs you. Let's get into them. The first is OpenScience. According to a post by Daedalus Sin Science that reached 81,000 views and nearly 900 bookmarks on July 5th, OpenScience is an open-source, multi-model platform being reported as an alternative to Claude Science. The headline numbers are 250 or more research skills and integration with a multi-agent system called Atlas. Crucially, the design is explicitly vendor-agnostic, no lock-in to a single model provider. What does that actually mean in practice? Instead of wiring your research pipeline to one proprietary model and hoping the provider does not change pricing, deprecate an endpoint, or shift capability in a direction that breaks your workflow, OpenScience is built to route across multiple models simultaneously. The Atlas integration handles the multi-agent coordination layer, so you can swap the underlying model without rebuilding the pipeline around it. For engineers running research-heavy workloads, literature review, data synthesis, structured output generation, this matters because vendor dependency is a real operational risk. The engagement on this post, 843 likes and 888 bookmarks in roughly 24 hours, suggests the community recognizes that. Portability is not a nice-to-have when model providers are still moving fast and pricing is still volatile. The second story comes from Alex Prompter, who expanded on a discussion by Boris Cherny of Anthropic around advanced Claude Code agent workflows. The pattern being described is what is being called writing loops, and it is worth understanding precisely what that means. A writing loop, as discussed in this thread, involves running multiple Claude Code instances in parallel rather than sequentially. Each instance has a defined role. One generates, one writes to a shared memory file, one verifies. The verification step is not bolted on at the end. It runs concurrently, catching errors mid-loop, rather than surfacing them only when the full task completes. This is a meaningful architectural shift from how most teams currently use code agents. Single-threaded prompting, send a prompt, wait for output, review. It's a ceiling quickly on complex multi-step tasks. The context window fills, errors compound, and you end up doing more manual correction than the agent saves you. Parallel instances with memory coordination and inline verification change that ceiling. If you are building automation that involves more than a few sequential steps, this pattern is worth prototyping. The engagement on the thread, with hundreds of likes and bookmarks, suggests engineers are already paying attention. The third story is about infrastructure economics, and it comes from Arstock Savichet, whose post on Google's TPU Compute Advantage drew 104,000 views and over 1,300 likes on July 5th. The discussion centers on how Google's own silicon strategy, designing and operating its own tensor processing units, rather than buying GPU capacity from third parties, creates a structural cost advantage for running frontier models at scale. The logic is straightforward. When you run inference on rented GPU infrastructure, you pay the hardware provider's margin on top of your own operating costs. When you run on silicon you designed and own, that margin disappears. At the scale Google operates Gemini, the compounding effect of that cost difference is significant. Stock Savichet framed this in the context of Google profit outlook, but the downstream implication for builders is more direct. If Google's per-token inference cost is structurally lower than GPU-dependent competitors, that advantage can be passed through to API pricing over time, or used to run larger models at the same price point. This does not mean every workload should route through Gemini, but if you are making infrastructure decisions for high-volume production systems, understanding the cost structure of the providers you depend on is part of the job. Silicon ownership is one of the clearest long-term levers in that cost structure, and Google is currently the provider with the most mature owned silicon deployment at frontier scale. To bring it together, today's three stories each point at a different layer of the stack. At the application layer, OpenScience offers a vendor-agnostic research platform worth evaluating if you are locked into a single provider. At the agent architecture layer, writing loops with parallel instances and memory files represent a practical pattern for scaling complex automation. And at the infrastructure layer, Google's TPU economics are shaping the long-term cost curve for Gemini-class inference in ways that matter for production planning. None of these are announcements to watch from a distance. All three have something you can act on this week, whether that is pulling the OpenScience repo, prototyping a parallel agent loop, or revisiting your model routing decisions with infrastructure cost in mind. That is the build for today. Sources are in the description, attributed to the original posts. If this was useful, subscribe. We do this every day.